Hello, in this video we are going to have a look at an actual practical example, I suppose, in terms of transformations. And I guess I wanted to start by highlighting what I've written here, which is that order matters in transformations. So you can see that I've got four transformations that I'm going to make to this base or parent graph of f of x equals root x. And we'll go through those in a second. And you might note that underneath here you can see that I've got the same four transformations, but in a different order, because order does matter. Not precisely, but there is definitely a grouping of orders that does matter. And I probably won't even talk about that too much, rather than so I'll just get on the screen a bit, just to make things not too complex. But we're going to see what happens when we apply the transformations to a function. In this particular order, and we can see how we're going to build up to the brand new function. So at the end of these four steps, we're going to have a brand new function. Let's just say it's f of x here and g of x to finish off with. What each of these transformations does is it creates a brand new function, and then what we do is the next transformation is applied to the brand new function. So every single step you need to think about, I'm actually transforming this function. You might remember last video, I said that transformations normally apply from a base function, but they don't have to. You can transform any function that you've been given, as long as you are just careful and considerate with what you're doing. This is effectively what we're doing here, but we are starting with a parent function. That's like step 0, but every next step basically gets us one new function along the journey to the final function we're looking for. Okay, so anyway, let's just get into it. What you basically need to do for each transformation is you need to work out whether it's going to be something that impacts the input or the output. Here we have number 1, translation. Okay, so we know that's up and down or left and right of 3 units to the left. Now, if the graph is moving this way, then that's because I've transformed the input, right? Because each of the inputs or each of the x coordinates is shifting over to the left. It's shifting over that way. Okay, so step 1 is to note that I'm not going to be adding or subtracting 3 to the whole function. I'll be replacing the input x with a new expression. In this case, I need to shift things over to the left. Now, if I'm shifting over to the left, then I'm going to have to counterintuitively add 2 to the input. So I'm going to go x plus 2. So the x, which is the old input, has a new input, which is x plus 2. Okay? So if I just zoom that out a little bit, you can see it's now shifted over by 2 units. And again, just to remind you, that's because to get to the same value, say 0, 0, I'm going to have to start further back to get to 0. Okay, so x has to be minus 2 just so that when I add 2, I get the square root of 0. Okay, so that's why counterintuitively we're adding 2 to move to the left. Okay, so there we go. Step number 1. I've got a brand new function, and it's the end of step 1. So I started off with the square root of x, and now I've got the square root of x plus 2. Reflection about the x-axis. Okay, so looking at my function here, I'm going to go from, if I'm doing a reflection, it's going to go from here, if this is the mirror image, to down here as well. So you can see here that if I do this, just thinking about it, my x coordinates are not going to change. Only my y coordinates will. So that means that this is a output reflection. Okay, it's an output reflection. So in order to make it reflect about the x-axis, I need to take the whole new function, square root of x plus 2, and make the whole thing negative. And because x plus 2 is completely underneath the square root sign, I can just put a negative outside the front there. And now we've got negative root x plus 2. If you like, I can put this underneath. Maybe we can just build it up one bit at a time. And you can see it's now, this purple line is a reflection of the green line. this function has been transformed twice, once, twice. Okay, so we've gone from root x to root x plus 2 to negative root x plus 2. The next one is a vertical translation 2 units up. So if you see up and down, we know that's going to affect the output, not the input. These values aren't shifting this way. The x coordinates aren't shifting, only the y coordinates are. So again, it affects the whole of that function, not just the inside bit, not just x, but the whole of that function. Okay, so that means that step 4 is going to be taking the whole of that function, and we're going to shift 2 units up, plus 2. So the black line here is a shift of every single y coordinate has been shifted up 2 units. Okay, so we've got another build happening here, negative x plus 2 plus 2. And then finally, this is the bit which I think is probably the most tricky to get right, I suppose. We've got a dilation not from the y-axis but to the y-axis of factor 1/5. It's a shrink of factor 1/5. Now, if it's dilating to the y-axis, then we are compressing that graph. We are squishing all the values in a lot more closer to the y-axis. They're all being squished in this way and squished in this way. Okay, so that's not going to affect the y values as such. It's going to affect the x values. All these x values are going to be squishing in. Okay, so that means we now need to replace the input of this function, which is x, and replace it with not 1/5 of x, but 5x, because remember, the squishing effectively accelerates the values of x. And so if we're squishing by a factor of 1/5, we need to multiply x by the inverse of 1/5, which is 5. And so it looks like that. So this red graph here, this final red graph here, you can see this has been squished in by 1/5. This has been squished in by 1/5. This value hasn't changed, of course. The black line and the red line here hasn't changed because when you take 1/5 of 0, it's 0 as well. Okay, so that stays where it is. So everything has been squished in. Okay, so the final line then, so I'll just put another arrow here, and I've now got, let's call it g of x for the transformed function. We've got g of x is equal to negative the square root of 5x plus 2, and then another plus 2. There we go. Okay. Now I just realized as I was writing that I did say a translation of 3 units left here. So I will just fix that really quickly. I thought it was a bit odd that I'd use 2 twice, just to make it consistent with the notes there. There we go. That's how it should look, like a translation of 3 units. Now this graph, it resembles the original graph in many ways, but it is quite different in its shape, really, in its starting point and where it's going and so on. But you can see it's kind of like a curvy thing here, and it's a curvy thing here. So it's not radically different, but it is quite different. So there you go. So that is that example. We're going to do exactly the same thing, but this time we're going to do the transformations in a different order. So I'm going to turn these or get rid of these ones. I'm going to start by copying this again. And we're now going to follow through. I'll do it a little bit faster this time. The first thing we're going to do this time is to do the dilation. So dilation towards the y-axis of a factor of 1/5. So for the same reason I said before, we're just going to replace the old input, x, with the new input, 5. Okay? So you can see that these have all stretched closer by a factor of 5, or factor of 1/5, sorry. They're a 1/5 shorter. Okay, so that's that one. Reflection about the y-axis, about the x-axis, sorry. So we'll do that next. So we look at that and we say it's a reflection about the x-axis, so that affects the output. And because it affects the output, I'm going to put the negative outside, like so. So now it's there. The third step is a translation of 3 units left. Now a translation to the left affects the input, right? All the x values are changing. So look at what happens here. This is kind of really important to see what I'm doing here. The input is x, so I replace x with that translation to the left, so it's x plus 3, like so. Okay, that's what it would be. Negative root 5 outside of x plus 3. So x, the input, has been replaced with a new input, which is x plus 3. Okay, so we've gone from root x to root 5x to negative root 5x to negative root 5x plus 3, which is equal to negative root 5x plus 15. Have a look at that as a difference. Here, we're going to have 5x plus 2. Here, we're going to have 5x plus 15 because of that dilation occurring first. Okay, so it does make a big difference to our graph. And then finally, a vertical translation of 2 units up. So up and down is an output kind of operation, and so it applies to the whole of the function. So this gets 2 added to it. So we go f of x equals negative square root of 5x plus 15. Same thing. And then we're going to have plus 2, like so. So the black line, which was covering the purple one before, is now gone 2 units up. So it's here. So just to compare again, so you can see that it's, again, just to turn off the ones in between. So each of these is a brand new function. This is our final function. It's effectively g of x. Okay, so we can see that the original function has been transformed, and it doesn't look like the old one. The one from the example before was g of x is equal to negative the square root of 5x plus 2 plus 2. So there's that one that we did from the original 4 transformations, these ones here. And then the black line is the transformations from the second one. Even though they're the same set of transformations, they have created 2 separate looking functions. Not massively different, but different enough that you could say that they're obviously very different functions, really. So keep that in mind, that order does matter, and getting that order correct is what you need to practice, I think. So I'll leave it there for this video. In the final video of this series, I'll have a look at what happens if we've been given a function that's already been transformed, and you are required to write those transformations down.